Hello everyone, this is Katish here. In this video, I'm going to go through question number 6 from the June 2022 Combined Science Chemistry Paper 1 higher tier. Question number 6 is on bonding structure and the properties of matter. So in this question, complete the dot and cross diagram to represent the bonding in hydrogen chloride. Use dots and crosses to represent the electrons. So if I use the dots for hydrogen and the cross for chlorine, remember chlorine has 7 electrons in the outer shell. So there would be 1 electron from hydrogen and 1 electron from chlorine, which is being shared. And the rest of the 6 electrons in chlorine is not being shared, will be on the outside. Hydrogen chloride dissolves in water to produce hydrochloric acid. Hydrochloric acid is a strong acid. What is meant by a strong acid? Well, strong acids are those that ionizes completely or dissociates completely in aqueous solution, which means it breaks up. So HCl breaks up completely into H plus ions and Cl minus ions. If it was a weak acid, then it wouldn't be completely dissociated. Describe how magnesium can be used to distinguish between a strong acid and a weak acid of the same concentration. Now, magnesium will react with hydrochloric acid to form the salt and hydrogen gas. If it was a strong acid, then the magnesium will dissolve faster, whereas with a weak acid, it dissolves slowly. So, fissing or effervescence or magnesium disappears at a greater rate with a strong acid. Question, oops, the answer is already there, never mind. The concentration of hydrochloric acid is increased by a factor of 100. What is the change in pH? The pH decreases by a unit of 2. So for example, if it started off with a pH of 3, then it would actually go to pH of 2. A unit of 2, so that's actually 1. Question 6.5. Ethene and hydrogen chloride react to produce chloroethane. The displayed formula equation for the reaction is the one that is given here. This reaction is exothermic. In the reaction, the energy released forming new bonds is 56 kilojoules per mole, greater than the energy needed to break the existing bonds. Now, where are you breaking the bonds? You are breaking bonds here. And you're making the bonds here to form chloroethane. Now you have carbon hydrogen bonds, 1, 2, 3, 4 of them being broken, and 1 carbon-carbon bond and 1 carbon chlorine bond. These are the bonds which are being broken. And the bonds that is actually being made, you have carbon-carbon bond is this one of them, and there's 1 carbon and chlorine bond, plus you have 1, 2, 3, 4, 5 hydrogen carbon bonds, so which is also 413. So if I split that into 2, this bonds are being broken and this is being made. So the energy, what they're saying in the reaction, the energy released forming new bonds is 56 kilojoules greater. So 56 kilojoules greater, this is also in kilojoules. So this total amount of energy is equal to that. So we need to find the missing value of X. So let's do this calculation separately. Bonds broken is 4 times 413 plus 1 times X. Actually, let me write it as carbon-carbon double bond. That way it won't be confusing. So carbon-carbon double bond plus 431. So let's bring in the calculator for this. 413 times 4, 1652, add 431, that's 2083. So that's 2083 plus the carbon-carbon double bond. Bonds being made is 346 plus 339 plus 5 times 413. So 5 times 413 gives me 2065. Add that to 339. Add that to 346. Gives me a total of 2750. 2750. So energy released let me bring it up. Good. There you go. Equals bonds made minus the bonds broken, which is 56 should be equal to 2750 minus the 2083 plus the carbon-carbon double bond. So I take away 2750 minus 2083. That gives me 667. And I should 56 equals 667 plus C double bond C. Now that carries a negative value, doesn't it? No, that would be the negative. Sorry, let me rewrite that again. That is going to be 56 equals 2750 minus 2083 gives me 667 minus the carbon double bond here. So the carbon double bond will be 667 minus 56. That gives me 611 joules. That brings us to the end of the video and the end of this paper. Thank you for watching. I'll see you in the next paper.